said 36. 36 looks like this. Okay, we starting?
Yeah, it's already been recording.
36, you've got two segments that are parts of secants out here. And we know if they meet outside, then I'm going to take the difference between the two arcs, which in this case is 170 and 20 degrees, and then divide by 2, and it'll tell me to measure that angle. So it's 170 degrees minus 20 degrees divided by 2. I think that's 150 degrees divided by 2, which gives us 75 degrees, and that's a reasonable answer for that. Okay, it's not drawing very well up here, but on the paper it looks really good. 37 is the same kind of question. We have two line segments that meet outside the circle, so we're going to do the difference again. It's 178 degrees here and 58 degrees here. So it's 178 minus 158 divided by 2, which I believe that's 120 divided by 2, so the answer is 60 degrees. Okay? What's up? Thank you. Now it's right. Yes? Number 38 and 39 are the same kind of question, but you can't do 39 in the same way that you do 38 or you'd get it wrong. 38 says we've got these two line segments that meet inside the circle, and you've got 130 degrees here and 95 degrees here, and we're looking for angle 1. So that one's easy. We're going to add them and divide by 2. 130 plus 95 divided by 2.
112 plus 112.
Well, it's 225 divided by 2 is, yes, 112.5 degrees. Yes? Easy problem. So what's the difference between that one and 39?
Subtract.
No?
You add.
Still going to be adding, but that's not going to tell you 1. It's going to tell you this angle. So what do I do with this angle to figure out what angle 1 is? Subtract it from what? Guys, what relationship do these two angles have? That
Subtracted from 122.
They're a linear pair, so they're supplementary then. So once I find this angle, I can subtract it from 180. Okay. Can't see what? If you're talking about the diagram, the board isn't as good as the one on your paper. Hopefully you're looking at problem number 39 right now on your paper. So 32 plus 122 divided by 2 is 154 divided by 2, which is, that's not the answer. That's just telling you what this angle is. Now we're going to subtract that from 180, and that should tell us the answer. 103 degrees, yes? Okay. Number 40. I was watching some of you working this problem out on Friday, and you were doing some silly things, like multiplying 16 times 18. Remember, they have to be in the same segments. This is a simple rule. It's A times B equals C times D, yes?
So 16 plus.
So 16 times, I believe, 20, yes? And then 18 times, so we'll put 18x equals 16 times 20. That means 18x equals 320. Divide both sides by 18. 17 and 7/9 as a decimal. That would be about 17.8 or 17.78, depending on how many decimal places you take. Do you need to sit up here so you can see better? I can pull another chair up.
Me?
No. Evan.
How is he going to tell you to sit up there if you're up there?
Well, some cases he has trouble seeing the board, so. Nope, Mr. Nevin doesn't want to come up, so we're good. 41. Now in this case, notice I put 4 bullets there. They could all be right, or they could all be wrong. So we're going to take them one at a time. Which of the following statements about figures associated with circles is true?
Diameters
As secant intersects a circle in 2 points. Is that true or false? That's true. Okay. A tangent line is perpendicular to an intersecting radius. Here's what a tangent line looks like. Here's the intersecting radius. Is it perpendicular?
Yeah.
Yes, it is. A diameter is a chord.
That's true.
That's absolutely true. Now, if it said a radius is a chord, that would be false. It's got to touch both sides. Both endpoints of the line segment need to be on the circle. Okay? A radius, that's not true. A tangent segment is called a chord. Is this called a chord? No. So that one is false. The others are all true. Okay, now 42 is a question we kind of went over a couple of times, but nothing like the other problems. We only did this a couple of times. As it turns out, if you have a radius or a diameter that is perpendicular to a line segment, it bisects it. So if this is 3x and this is 12, what do I know about 3x and 12? They are congruent. They're equal to each other. So x is 4. Easy question if you know that trick. It's not that hard to do. 43, do you remember the rule?
Yes. Outside times outside plus inside.
Keep going. Equals.
Outside plus inside.
That's exactly right.
I'm so proud of you, man.
Actually, I'm expecting most people to get this question right because you guys did so well on the last test. Okay? So 3 times x plus 3 is equal to 4 times 4 plus 7. 4 plus 7 is 11. 11 times 4 is 44. Don't forget to distribute on this. People get it wrong when they put 3x plus 3. It's 3x plus 9. Then we subtract 9 from both sides. If this problem looks familiar, it's because it's the same question from the circle test review. Okay. That brings us to question 44, which I did not cover any of this, 44, in class. Well, that's not fair, Mr. Medic. You're going to give us a question that's not in class? No, I said I didn't. It showed up in the cognitive tutor over and over and over again, and all of you saw this question. Okay? They have this thing called the arc to circle ratio. Remember that? Okay, and it turns out if you're looking for the area of a sector is a piece of a circle, kind of like a wedge of pie or a wedge of pizza. So if I want to know what this area is right in here, and I know that that's a 70-degree angle, and that they tell us that the radius is, what did they tell us the radius was?
3 inches.
3 inches. Then I should be able to find out what the area of that sector is. I'm going to take the arc to circle ratio, and I'm going to multiply that times the formula for the area of a circle. What's the formula for the area of a circle?
R squared.
IR squared. Because this is like telling you a percentage. In this case, it's 70 degrees. Compared to a whole circle, what's the whole circle?
360.
360. So there's our percentage of the whole circle that we're looking for. And now we're going to write the whole circle's area, which is pi times 3 squared. And this one actually works out kind of nice. I can go ahead and divide both that by 10 and 10. Degrees over degrees is going to cancel. What do we get? Yeah, but it's not that hard to do. It's arc to circle ratio times the area of a circle. Yeah, that's not going to be given to you on the test.
Not hard.
You have to memorize
You know,
that.
not hard. Usually.
So we end up with 7 over 36 times, what's 3 squared? 9 pi. And you'll notice the 36 and the 9 will cancel, won't they? And what's that leave me with? 4 in the top or the bottom? On the bottom. Okay. So I get 7/4 pi, which if you punch that in the calculator, it's pretty darn close to 5.5. Okay. Last page. Hey. That was question number what? 44. So now we're on to. Where is 45? There it is. It's actually not last page. 45. Now, what you can't tell because it's kind of poorly drawn is that there's a shaded region on this diagram. It's the part of the square that's not in the circle. So it's asking you what this area is. Okay? They also tell you that the radius is 20 meters. So let's make a plan. How are we going to find the area of that shaded section? Length times the width will tell me what? Area of the square. So I'm going to find the area of the square. What else will I have to find the area of?
The circle.
Area of the circle. What will I do with those once I find them?
Multiply them.
You subtract both of the
I'd say I'd take the square and subtract the area of the circle, don't you think?
Yeah.
Okay. Well, in order to find the area of the square, I have to know the lengths of its sides.
Yeah.
If this is 20
meters.
40.
What's this? Yes, it's
40
40.
meters.
That's correct. It's 40 meters because 20 is the radius. So if I put another 20 meters on this side, that would make it the diameter, which would be 40, which is the same as the length of one of the sides. Right? That makes sense now? So the area of the square is easy. It's 40 times 40. Area of the circle, you've told me it's pi r squared, right? So pi times what squared?
20 squared.
Okay. What's 4 times 4?
16.
We get 1,600.
He said 8.
20 times 20?
400.
Technically, that's an answer right there. If I said leave it in terms of pi, that would be the answer. Now, if I plug that into the calculator, I can get a decimal equivalent.
1,256.
I don't think so. I suggest you write 1,600 minus 400 times pi in a calculator. You would get about 343.4 square meters. And the answer is going to look like one of those two. I'm not saying which. 46. Okay, there's something that I didn't tell you that you have to figure out on this. What did I just draw?
A diameter.
A diameter. It's a triangle inscribed within a circle, and the hypotenuse, that's your giveaway right there, is the diameter. Now, how do I know that's a right triangle? Well, if that's a diameter, how many degrees are from there to here?
180.
And this is an inscribed angle, which is always half of its intercepted arc. So what's half of 180?
90.
That means that is a right angle, isn't it? The question they ask you is to find the area of the circle. How do you find the area of a circle? Well, that requires you to know
R.
But they don't tell us R.
Hell no.
Can you find out how to
But could I find that diameter?
Yes, you
And
can.
then what would I do to find the radius?
divide by 2?
Divided by 2. So in other words, 6 squared plus 8 squared equals the diameter squared, doesn't it?
Yes, it
Does
does.
anybody know what the diameter's length is already? No?
Yes.
Guess we'll keep going then. 36 plus 64 equals the diameter squared. Do you know what 36 plus 64 is?
100.
So what does that make D?
50.
Wrong.
10.
Dude, square, not half. Square root.
Oh.
So what's R?
5.
Yes, which makes pi r squared, pi times 5 squared. 5 squared is?
25.
So 25 pi is one version of the answer. Now if I punch it in a calculator, I get 78.54.
It's okay if we keep it at 25 pi.
Depends on which one the test gives you, and I'm not saying which one. Okay, it could be either one.
Play games.
47. Oh, I need the graph paper, so I'm going to erase this thing. Which means I need to erase that part too.
Wait, I'm not doing calculation.
You should have done that.
No, it's alright. I'll just use this hat.
No, I did it, but I'm not.
I think I could pretty much do it right here anyway. Yeah, I can. Okay, when you get to get to an Algebra 2 class, the teacher's going to require that you carefully mark your coordinates on your graphs. You're going to notice that I use a regular scale. That means I use the same space between every number. It doesn't really matter what that number is or what that space is, but it has to be the same. So you can't use odd numbers because the space between 0 and 1 is 1, and then the space between 1 and 3 is 2. So that would be what's known as an irregular scale, and that's not the correct way to do it. Okay? So here, every space is 3 for me, isn't it? 9 is up there. That's a horrible 9. That's a better one.
Is that a 47?
So this is 47. Sarai plots and connects the following points. A is at 0, 0. B is at -5, 0. So we got that side growing so far. We're going to draw a quadrilateral and decide which kind of quadrilateral it is. C is at -7, 3. Right there, that's C. I don't know what this is going to end up being here. And then D is at 3, 3, which is right there. So what is it? It's a trapezoid. Is an isosceles trapezoid or just a trapezoid?
Jeffrey says just a trapezoid.
Jeffrey would be right if he really said that.
That's it.
This side's length, if you'll notice, there's only 2 units this way and 3 units this way. This one, this hypotenuse is 3 units and 3 units, so this one's longer than that one, so it's not an isosceles trapezoid. It's just a trapezoid. And that brings, which question was that? That was 47. Now we're going to get into some similarities. So let's talk about what's necessary in order to prove 2 triangles are similar. There are 3 ways to prove them. Remember what they are? Side, side, side similarity. What's another one? Side, angle, side similarity. And then the third one?
Donkey.
Angle, side.
No, just angle, angle. Yeah, we don't need another side if the 2 angles are congruent and the triangles have to be similar. The one we end up using the most often is this one. Okay, it's just really simple to do. If I can prove that 2 angles and 2 triangles are congruent, then the 2 triangles must be similar. Okay, so on 48, you got a diagram that looks like this. Can I prove that those 2 triangles are similar?
Yes, you can.
By angle-angle similarity, because these 2 angles are congruent because they're right angles. These 2 are congruent because they're what kind of angles?
That's cool.
They're vertical angles. So the 2 triangles are similar, that means I can write a proportion. The numbers they give us are 7, 12, 8, and x. What's the proportion? What is to what is what is to what? 7 is to 12.
8 is to X.
Is it 8 is to x or x is to 8? Which one corresponds with the 7?
X.
X does. Okay, spit out whatever it is you're chewing here, Mr. Raditich. So 12x is equal to 7 times 8.
56.
So, divide both sides by,
12.
and this one does not come out 9.
No, it doesn't.
Yeah, it's I think 4 2/3.
Yes, sir.
If it were a decimal, 4.7 or 4.67. 49 and 50 are both about parallel lines. I hope we remember some of our parallel lines relationships. 49 starts off like this. And we've got a 42-degree angle over here, and 3x plus 15 degrees over here. Number 1 mistake on a question like this on the final is for students to say those 2 are congruent. Let's talk about why that's a ridiculous thing to say. What kind of angle is this? Is it an acute, right, or obtuse?
Acute.
Acute. What about this one?
Obtuse.
Can an acute angle be congruent to an obtuse angle?
Of course not.
So that's not the relationship.
They're linear pairs.
They're not a linear pair because they're not at the same intersection. They're actually what's known as same side exterior angles. And anytime you say same side exterior, that means, or interior, it's going to be supplementary. Right? So 3x plus 15 plus 42 is equal to 180. 15 plus 42, 57. Subtract that from 180, I believe we get 123, which happens to divide nicely by 3, and you get 41 degrees. Which brings us to question 50. Question 50 has a pair of parallel lines again. This time they're running this way, though.
Nice. Now. Oh, well. Whoops.
And this one's 70 degrees. This one doesn't have a direct relationship. You can't point at that one and say, oh, they're same side. They're not. Alternate, no, they're not alternate, no, they're not alternate exterior. They're not corresponding, they're nothing. So there's got to be some other relationship that we could connect. Well, that angle and that angle are congruent because they're what? Oh, that's sad. You're making your math teacher upset here. Corresponding angles, ladies and gentlemen. If they're corresponding angles, then they must be congruent, which means this one's 6x minus 10, isn't it?
Yes, it is.
What relationship are these two? Because they form a
Linear pair.
linear pair. So 6x minus 10 plus 70 equals 180.
Yeah, just one.
And so what does 6x minus 10 plus 70 simplify to?
6x plus 50.
Plus what?
50.
Oh, that's a 60, is it?
That's a
So 6x equals 120 then, so x is...
20.
And if I plug a 20 in here, I'm going to get 110. Is 110 and 70 degrees supplementary?
Yep.
And we did it right. Okay, you can tell on the test yourself if you got it right without having to have Mr. Medic verify it. I apologize. Microsoft Word decided to renumber the problems on this as I was writing it. That's why there's two 51s. So there's actually 59 questions on this review. There are 44 questions on the test. Okay? I gave you more practice on the review. I wrote this test question. I wrote this review question last week when my friend texted me that he was in Del Norte forest amongst the redwoods.
Wow.
So the first thing I have to say is that those two triangles are similar. How do I know they're similar? What does that M stand for, those of you who've read the problem?
Middle. No, wait.
It's the mirror. So we know that as the light comes into the mirror, it's going to refract and bounce back out at the same angle it came in. That's called the angle of approach, is the same as the angle of departure. Because of that, since I've got two angles in this, are congruent to two angles in this, the two triangles must be similar, not congruent. And my friend Dan, he's about 6'2", so his eyes would be about 6 feet off the ground. So I just made these numbers up and came up with a reasonable situation. So what would my proportion look like? What is to what is what is to what?
X over 143.
That's the easy way. Equals what? What?
6 over 13.
Thank you. So 13x equals 6 times 143. What you may not notice is that I picked 13 to divide evenly into 143. You know how many times 13 goes into 143?
I do.
11 times. 11 times 6 is... So the answer is 66 feet. Is it reasonable to have a redwood tree that's 66 feet tall?
Probably not.
Yes. There's thousands and thousands of redwoods that are over 6 feet tall. Okay, some of them are over 300 feet tall. Okay, that was 51 number 1. Here's 51 number 2. 51 number 2.
51.
How do I show that these two triangles are similar?
You look at them.
That's not enough information.
Um,
Yes. If the sides are proportional, which one are we using here? Side, side, side. But we got to show that they're proportional. So let's write a three-part proportion. So we'll start with this one. 2x compares to what on this one?
3x.
And if I divide the x's out, I end up with the fraction 2/3, right?
Yeah.
Okay, I'm going to skip the middle one. I'm going to go to the end one. That's 4x.
Over 6x.
Yes. Now, will that simplify to 2/3?
Yeah.
okay, I guess this.
So do you think this one might? 3x compared to 4.5x?
I think it might not.
Let's find out. The x's cancel. If only I could find the same number that would divide into both of those.
12.
1.5 divides evenly into both of those.
How is 12?
How many times does 1.5 divide into 3?
Twice.
Twice.
How many times do you think it divides into 4.5?
Twice.
3 times.
3 times.
3 times. So guess what it simplifies to?
2/3.
Another way to do that, guys, is to, if I don't like a decimal, I can multiply both the top and the bottom to get rid of it. In this case, multiply by 2. I'd get 6/9. Does 6/9 reduce to 2/3? Yes, it does. So these two are proportional because of side, 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 similarity.
So is it? You get it?
Got somebody here speaking parsons tongue.
You get it? 'Cause
Glad somebody laughed.
Well, I understand.
My family is so into Harry Potter that they just, they like, oh, that's a good one.
that was my mistake.
Medic.
Whatever.
Medic.
Huh.
You know how to speak Klingon?
Tratna jit.
Oh,
Are you okay?
I just said that I'm a human. And if you say that, a Klingon thinks that you're asking for help.
Klingon, like in Star Trek?
Like
when
in
they
Star
go-
Trek. Okay, I'm going to write these because it's a little hard to read in here. They're asking, I think this is 1, 2, 3, 4. Is that right? That's written. Yes? Okay, and then these two lines are parallel. And does this say 3, 4, 5, 6?
5, 6, 8, 7,
What number is this right here? 5. 6?
7, 8.
Okay. These are the reasons. By the way, there's a missing statement in here. I call it 4B. And these are the statements. And our goal at the bottom, number 6, says angle 3 and angle 6 are supplementary. Number 1 says L is parallel to M.
Given.
Yep.
Come on.
I'm sorry, I'm not going to give you that question on the test.
You're not going to give us the given?
You're going to have a page that has the proof on it. It's going to have spaces for all the reasons. Only 2 reasons will be missing. Obviously, I'm not going to have given missing because that's too easy.
Because that's
No, it's
given.
not. What if I just-
2 says that angle 2 and angle 3 are supplementary. Here's angle 2, here's angle 3. Why are they supplementary? What relationship does this mean?
They equal what they need.
They're a linear pair. So guess what that reason here is? The linear pair
Postulate.
postulate. Actually, if you remember, the first time we did stuff like this, everybody was scared to death.
Yeah, we was.
And it doesn't seem that big, ugly, hairy, and scary anymore, does it?
You know, it seems to be beautiful young lady.
I don't know about that. And then it says a measure of angle 2 plus a measure of angle 3 equals 180. Who knows the answer to this one? Raise your hand if you know what it is. Only a couple? Really? Up here it said that they were supplementary. Here it says that their measures add up to 180. Mr. Chitness, what do you think?
Wrong.
Say again? Nope, not that. Yes?
The definition of supplementary angles.
Mr. Singh correctly identified. It's the definition of supplementary angle.
Hey, boy. What?
Question 4 then says, and it has nothing to do with these two statements,
Angle 2.
angle 2 is congruent to angle 6. Why is angle 2 congruent to angle 6? Corresponding angles is correct. Called the corresponding angle postulate. Now for 4b.
Resting down.
Okay, the statement that's missing, which you can write right here, is the measure of angle 2 is equal to the measure of angle 6. Now that's necessary for us to do the next step. We have to say that those two measures are equal. How do I know the two measures are equal? Because the two angles are what? So that's the definition of
Congruent angles.
That's good.
5. Now we're saying the same statement we said on number 3, but something's changed.
They substituted.
Yes, that's the substitution property. Good. I wonder why that's funny. It says actually measurement of angle 3 plus measurement of angle 6 is equal to 180, right? And then finally, it always blows my mind when somebody says for number 6 the name of the thing that they were trying to prove. Guys, you never say what you're trying to prove. You never say it. At the end, you have to have a good reason for why this lets me say this. So this says that their measures add up to 180. This says that they are...
Supplementary.
So what's that reason?
Linear pair.
No. They are clearly not a linear pair. They're nowhere near each other.
Oh God, I didn't see that.
What about subdistance?
They equal 180.
In other words, that's the
Flexive property.
the definition
of
of supplementary angles.
We did it again. No, we just did this whole thing for y'all.
Guys, the definition always goes both ways. So I can start from the definition and say that they're supplementary, or I can start from them being supplementary and then say the definition. That's the way the definition works. It's a two-way street.
I know you can use one reason.
Okay. Yes, you may use the same reason 5 times in a proof.
I'm going to do that.
Substitution shows up over and over and over again in algebra.
Here. From the gym.
Okay, 53. "53 says, oh yes."
It says, oh yes.
There's actually how many right triangles in this picture? There's 3.
I say 2.
So if I compare the little right triangle to the medium-sized right triangle, I can compare short leg to short leg and long leg to long leg. The short leg in this triangle is 4. What's the short leg in the medium-sized triangle? X. The long leg in the small triangle is X, isn't it? The long leg in the medium-sized triangle is 8. So notice that the X's are in the middle. That's not always the case. It's whatever this line segment is. Whatever that height is, that's what goes in the middle. So if this had said 4 and that had said X, the 4 would have showed up twice. Does that make sense? So then I'm going to cross multiply. X times X, please don't say 2X.
X squared.
Yes.
XX.
Equals what times what?
8 times 4.
Did I write that right?
8.
It's supposed to be 16?
16.
Thank you.
Come on, Mr. May.
What is 4 times 16?
48.
Nope.
64.
Yep. So what's X?
8.
In this class, it would be 8. If it were Algebra 2 next year, you'd have to say 8 and negative 8.
Oh, 2 answers.
Because there's always 2 answers when I take the square root of both sides. Okay? Except in geometry class, we discount the negative because that would mean this height is a negative number, and that doesn't make any sense. You don't have negative heights. And there's no unless. There's no such thing as negative heights. Now, for your benefits, the review question is actually harder than the test question this time. When I put this question on tests, students frequently get it wrong because they think that that means something that it doesn't. It doesn't mean they're congruent. Although in the question itself, this letter is Z and that's W, they say that those two are congruent. Now let me draw those two triangles separately so we can mark the parts that are congruent and see what the relationship is. They say that those two are congruent. The fact that these two lines are parallel implies something. What does it imply? Whenever we've had parallel lines, it's implied that there's something else that's congruent. What? Angles. Alternate interior angles. This one's congruent to that one, isn't it?
Yeah.
And then notice that this WY shows up in both triangles, doesn't it?
Yeah.
So this side is congruent to itself. We call that the what? Reflexive property. So, are those two triangles congruent? By what? SAS. Side, angled side. Yes?
Yes.
Okay. Number 55 has 4 sets of 2 triangles. Can I show that those 2 triangles are similar?
No.
Yes.
What would I do to x to get 2x? Multiply by 2. What about y and 2y? Same proportion then. Are these 2 angles congruent to each other? Because they are vertical angles. So that makes this SAS similarities. There was SSS similarity, SAS similarity, and angle similarity. And so this one's SAS similarity. Okay, then I got one over here that looks like this, and these 2 lines are marked parallel. Can I prove those 2 triangles are similar? What does parallel lines imply? Said it about 5 minutes ago. Angles are congruent. Specifically, this one's congruent to that one because they're corresponding angles. Therefore, the 2 triangles must be similar because they both share this angle, don't they? And these 2 are congruent. Therefore, by angle similarity, these 2 have to be similar, don't they? This one, C, I'm going to save you some hassle here. The answer to this one is no. The reason it's no is because they've marked the wrong parts congruent. Okay, some would look at that and say, well, that looks just like that one, but it doesn't. See how that has a right angle up there? This one doesn't, does it? So they're not automatically similar. It only happens if that's the right angle and there's a right angle for the height. In this case, notice that this is the hypotenuse, isn't it? Yes? This little triangle is the hypotenuse. Is this the hypotenuse in this triangle here? Really, I'm talking to myself here. Yes or no? Is this the hypotenuse in this triangle right here? No, they're not corresponding parts then, are they? So technically, this is side angle, which you can't use, or hypotenuse leg. Okay? And then this one would be side angle side. It can't be one way in one triangle and another way in the other triangle. They have to both be SAS or they have to both be hypotenuse leg. And that's why that one's not going to work. So this one's a no. It might be similar, but there's no way to prove it. Okay, and then D is a yes because of the fact that you've got 2 pairs of alternate interior angles that are congruent. This pair and this pair. And therefore, by angle side angle, those are similar. Actually, they're congruent. Okay? But congruent is similar. It's just better than similar. '56 is an easy problem. You see 2 triangles that might be congruent? Why? Why are they congruent?
Share a side.
Since they share a side, we've got what then? It is SAS. 57. Next to the last question. I don't like any of the answers there. We're going to come up with our own that makes sense. Okay, those don't. So we got L, M, and N, and P, Q, and R. So we're going to talk about ASA and AAS. Okay, by ASA, I need two pairs of angles and the side in between them. So in this case, let's take L and M. Angle L is congruent to, angle M is congruent to, and what's the side between L and M? Really? N is not a side. I need two letters, guys.
Oh, I'm sure.
Between these two angles is which line segment?
LM.
Line segment LM. Which angle corresponds to angle L? P. Which angle corresponds to angle Q? Angle M.
Q, you said it.
Yeah. And so which line segment must be congruent? Yep. That's if we're talking ASA, right? Now it's one possible combination. I could have said L and N and P and R, and then line segment LN and line segment PR. What if it's by AAS? Now this one's a little more complicated. Okay, I'm going to pick the same two angles. Angle L and angle M is congruent to angle P, is congruent to angle Q. But now I want the side that's not between them. Which side in this circle is not between L and M? Pick a side. LN. Now pick the corresponding side in the other triangle. PR. That would be AAS. Do you see? Yes? Okay, last one. Identify these constructions. Now you have an advantage because I'm alive. This paper is not. It's not going to show you all these steps in order. But this one, because I'm standing up here, you will see them in order. So what was the construction where we started with the line segment and then drew these two intersecting arcs? Do you remember what that one's called? It's the first one we learned.
Bisector.
What bisector?
Perpendicular.
Yep, that's right.
I'm so cool.
Okay, which construction starts like this?
A triangle.
Yes, so what kind of triangle? An equilateral triangle. This was the hardest construction. Some people still can't do it.
Parallel.
We copied an angle, yes. That was constructing parallel lines by copying an angle. There's another method. There's actually many different methods. For example, here's the ground. Here's a perpendicular bisector of the pole. And then we do another perpendicular bisector, and guess what we've just created? Two whats?
Mr. Medical line.
Two whats? Parallel lines. Two more.
Yeah.
This one, I know somebody's going to blurt it out before I even get it drawn.
Already, I'm going to try to.
Angle bisector is correct. It's an easy construction. Okay, now if anybody gets this one, I'll be kind of surprised because I don't think we did this construction. Anybody know? If I put my compass there and there, I'm going to find two more arcs that meet like that, and I'm going to be able to draw what kind of line here? Perpendicular. This is a perpendicular line through a point. On the line or not on the line?
On the line.
On the line. Okay, so we are done. Turn it off now.